Hi, my name is Warner and I'll be your chemistry tutor for this question. Let's start off by reading the question. What are the concentrations of all the solute species in 0.35 molarity of lactic acid? This acid has a Ka of 1.4 times 10 to the negative 4. Let's start off by underlining the important phrases in the question. Concentrations, the solute species, 0.35 molarity of lactic acid, Ka of 1.4 times 10 to the negative 4. So from the information given, this is hinting dissociation. Just from the word solute, we can already deduce that lactic acid is undergoing dissociation with water to produce a hydrogen ion. So before we go get ahead of ourselves here, let's consider Le Chatelier's principle. This young lad postulated that reversible reactions undergo shifts to reach equilibrium and counteract change. So let's consider this analogy of a water tube. And let's say they have equal amount of waters on each side before any change occurred. Now let's add some water on the left side. So the water that already existed before the added change will shift to the right in order to counteract the change from the left, which is going to allow the water on the right side to increase and introduce an overall equilibrium. In the same way, from the information given, we know that lactic acid has a 0.35 molarity while the hydrogen in the anion have no concentration whatsoever since it's not even given. So, from Le Chatellier's principle in the water tube analogy, the reaction is going to shift to the right in order to introduce a positive change in the concentration of hydrogen and the concentration of the anion. In turn, the concentration of the lactic acid is going to decrease. So even before any dissociation occurs, we need to understand what are the major species. So dissociation will only occur if water is present and some form of acid, which in this case is lactic acid. So we already know our major species. So from the major species, we have to determine which one of these is going to produce the most amount of hydrogen. So we can do it two ways. We can look at the Ka values or just through inference. Because lactic acid is going to be much more acidic than water, which is pretty much has a pH of 7. Lactic acid is going to be around maybe a pH of 4 or 3 tops. So it's going to be much more acidic than water. You can also look at the Kas because the because the K values tells us that this is going to be much more acidic compared to a K of 1.0 times 10 to the negative 14. So acidic, the lactic acid is going to be a stronger acid than water. So it's going to dominate the production of hydrogen. So we write an equilibrium expression for lactic acid. So it's just going to be the Ka equal to the concentration of hydrogen times the concentration of C3H5O2 over the concentration of lactic acid. So from the equilibrium expression, it's going to be quite helpful once we substitute the equilibrium concentrations into equilibrium expressions to find what the concentration of H is. So there are two methods to find the change in initial concentrations. We could do it algebraically. So we already know from Lecher's principle that the concentration of lactic acid is going to decrease and the concentration of hydrogen in the anion is going to increase. We don't have to change any variables such as like 2x, 3x, or 5x because from the dissociation reaction, we realize that it's all 1-to-1 ratio. So it's just going to be minus x or plus x. So we just write an equilibrium expression for the concentration. We see that's going to decrease for the initial concentration of lactic acid, whereas the concentrations of hydrogen is going to increase. We can do it through the ice table. It can be much more convenient to the eye, but it's going to take a long time to set up in cases of like tests and exams. Um, so we see that the reaction is going to the right. Concentration of hydrogen in the anion is going to increase, while the concentration of lactic acid is going to decrease. So we already see that the change is going to be negative for the lactic acid, it's going to be positive for the products, and we obtain some form of concentration for the final concentration of lactic acid and the hydrogen. So from these two methods, we can substitute the the concentrations into the equilibrium expression, which is going to give us x squared over 0.350 minus x. Since x here in this case in the denominator is going to be very, very, very small due to the small amount of Ka, we can simply just ignore the x. So it's just going to become x squared over 0.350. Through algebra, we find that x is going to be 7 times 10 to the negative 3, which is going to be the concentration of the hydrogen species and the anion species. Since in the problem it's asking us to find all the solute species, we have to find the final concentration of the lactic acid, which is going to be 0.43 molarity. To validate whether or not it was justified to take out the x, we can use this formula here, which is the change in the dissociation over the initial concentration of the acid. Substituting the values that we determined from earlier, we find that it's going to be 0.02%. Since the value is less than 5%, approximation is valid, and we could say that we correctly found the concentration of the solute species. We could also find the pH, but it's not specified in the problem, so I won't go over that specifically here. So in summary, how to find the concentration of solute species at equilibrium. First, we determine the major species that allows dissociation to occur. We choose the species which produces the most hydrogen, which comes down to um, which 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 species is the most acidic. In this case, lactic acid is the most acidic compared to water. So we focus on writing an equilibrium expression for lactic acid. Then we determine the initial concentrations from what's given in the problem. Through a nice table, we can determine the change in the equilibrium from the initial concentration to achieve an equilibrium concentration. So we substitute that expression into equilibrium expression, and we can find what x is through algebra. We could also, this is optional, we can approximate. Um, we could validate the approximation through using the formula we determined earlier. I hope this video was helpful. Thank you so much for listening. See you later.